I'm going to skip over the ignition tables, the VE tables, and bits and pieces because I think that like the priming pulse and crank pulse, this needs to be covered in a separate tutorial really on tuning, how to tune, same as the acceleration enrichment. So we're just going to go to spare output ports settings. This is there's a lot in MS3, a lot of settings that can be a lot of ports, a lot more ports in MS3 because there's an MS3X expansion card which has all sorts of I/O already built into it. But this is very similar to MS2 in that, say for instance, we've got a where are we? This one here, a cooling fan connected to the VVT output. Let's do it on okay, we'll use VVT for now. This is exactly the same. So basically you enable it, power on value of 1, trigger value of 1, and then once the coolant, depending on what there's hundreds of variables you can select from, but we're going to do coolant. If the coolant is less than 70 degrees, in my case, this is a light by the looks of it. So this light will come on whilst the coolant temperature sensor is less than 70 degrees. And the hysteresis means that if it goes to 70, if it goes 71, then come back to 70. It's got to go down to 67 before it'll come back on again. So the hysteresis is there as just to stop it flickering on and off. If it was a cooling fan, I'd say greater than, and probably 85 or 86, whenever you want your fan on. So that'd now be a cooling fan. If you connect it to that output to a relay. So I'm just using that as an indication that the engine's cold. This one here, RPM. This I'm using as an output to turn a fan on my intercooler. So once the engine's greater than 400 RPM, I know the engine started. So then that will turn a fan on the intercooler. I think I've used that in the past for power steering pumps as well, to turn electric power steering pumps on, that sort of thing. What else have I got on here? This is a CAN output because I'm using the CAN bus on mine. I've got an I/O extender, so I have quite a bit of I/O available on my system. And this is a rev limiter, a shift light basically. So when it hits 6050 RPM, that output CAN 03 will come on and turn the light on. This one here is manifold air temperature, MAT, manifold air temperature. Above 45 degrees turns the light on as well, so I know that the air temperature is too warm in the system and to drive carefully until that goes back down again. But you can use these as all sorts of things if you wanted to. There's lots of permutations you could have it so that's coolant was less than and also, or so it'd be that or one or the other, or that and for instance, so I could have it on throttle position. So if I put TPS, if I have TPS greater than say 80%, and a threshold of say 5 for argument's sake, so that wouldn't come on now unless the light wouldn't come on unless my coolant was less than 70 and I put my foot down above 80%. Then the light will come on to warn me that the engine's cold, or for whatever else I want to do. These are all outputs that you can use. If you're not using your Spark outputs on the MS3X card, you can use them. What you've got to be careful of is I'm using injectors A to H on my MS3X card. So if I selected B and I turned it on, the system will allow it, but I hope if I now switch it off and on again. Right, so you're saying I've got a system. Settings configuration errors because I'm using the injectors to power the actual injector. I'm using the injector outputs, but I've now asked it to set that pin up as something else. So this says here, conflict on spare output pin already in use by primary injectors. So I've got to correct that So if you ever see this settings configuration error, it's basically something you've just done since you've powered it on and off again. So there's two output ports used together, or two output settings that are used, sharing something. If you go in output pin use, this is MS3, but MS2 is the same, but it hasn't got this function. Somewhere in here that should say, if I can find it, doesn't say. Great example. I thought it might mention it, but it doesn't. That's okay. Well, anyhow, so spare port output pin already used by primary index. So I know it's a pin output. So while the ignition's on, go in here, find the pin that I've messed about with, put them back to 0, turn that off, burn that, close. Now if I switch it off and on again, hopefully that'll now be okay. Oh, I've opened the wrong, I'm on the wrong progress, because I've got two Tuner Studios run. There you go, we're okay. So we're back to where we were. Everything's hunky-dory. So if you get the conflict come up, basically that should give you a little description as to what's wrong. If MS2 sometimes does, sometimes doesn't. If it doesn't tell you, if you go into communication, mini terminal, switch power off and on again in the mini terminal, and you'll get a description here of the fault. So MS2 will give you an engine RPM of 6,900 or 69,000 something or other, and all the gauges will be lit, but you won't be able to do anything, and the fuel pump should be pulsing on, off, on, off. That's a classic case of configuration error. So just go into mini terminal, switch power off, switch power on again to the ECU, and you'll get a description here of what you've selected wrongly. If you're in trouble, and you just email me that description, I'll soon point you in the right direction. Right, boost control. If you've got boost control, and switch this on. Fast, slow reaction solenoids, the frequency of the solenoid. This you'll have to play about with, and just have a feel of your solenoid, feel if it's vibrating, if it's humming or whatever. You'll just have to adjust the frequency. 75 seems to work well. The pin that's used on, generally speaking, I will wire it in to the idle valve, or it's not actually on this setup, but if it's on if you're on MS3, then use boost, because the MS3X card you'll have. If you're on MS2, that'll be labelled on the lead as to which one to use. Output polarity is inverted on normal. That's just whether or not it needs to switch low to allow air through, or high to allow more air through. How often the system's looked at. Closed duty cycle, open duty cycle. These levels you'll have to have a play with. Open loop means it doesn't try and chase any target value, as in boost pressure. Closed loop, you can have it chase a boost pressure using these PID settings. It's a nightmare to set up, but it is, it is possible. Or if not, open loop just means it chases after just follows a pulse width modulation table that you have selected in there. There'd be a pulse width modulation, so you'd start off at 0, and as boost increases, you'd get up to whatever percentage you needed to get that sort of boost level that you wanted. Overboost protection. This is fuel or spark cut. So if you hit 150 kPa in this one, the fuel and the spark would cut, and cut spark for 3 cylinders out of every 7, so 3 events out of every 7, and so as you didn't go any further in than 150 kPa, and you'd feel that. You can switch boost tables with MS3 and MS2. I think you can do it with I think you can do it with MS2. And this is the input that switch boost tables on. Input needed. And the rest of it you'd have to play about with. I haven't really done much on boost tables and boost control settings. So, but it works very, very well from what I understand. You know, target table. So if you had closed loop, here, you'd have target table, and there's your kPa that you're actually aiming for. So that'd be the kPa you're aiming for if you had closed loop using this PID values. I'll turn that off because I don't need it. Obviously that's for a wastegate on a turbo. VVT, there's quite a good description of this. Really you need to go on the forums to sort this one out. There's an awful lot to this, depending on what sensors you use, and you need to know the angles that the the cam can move, and there is an awful lot of tuning to be done with this, but we can do it. We can run up to 4 VVT outputs, you know, like 4 cammed VVT systems, BMW for instance, can all be ran, but it needs a lot of tuning. Right. Where are we? Okay, manifold air temperature correction table. This is in MS2 as well. I'll go there in a minute. MS2 MAC correction table. Basically, what you can find is that the air temperature sensor, depending on where it's located, can get heated up, especially if you're sitting in traffic. The exhaust temperature can start heating up the air temperature sensor, and although the air coming in could be say 30 degrees, the temperature sensor could think it's 40 degrees, and because the ECU corrects the fueling depending on the air temperature, as air temperature increases it's less dense, so the ECU will add less fuel. So if it sees the air temperature sensors at 50 degrees when the air temperature is actually 30 degrees, it's going to add less fuel, so you're going to go lean. So this table here is to correct for that in traffic. So make sure you've tuned the car correctly, you know, at the ordinary air temperature values. Once you've got the engine tuned, if you're sitting in traffic and it goes lean, then you need to look at this table here, and this is just a graphical representation of this table. So on mine, once I start getting above 40 degrees, I need to add a little bit of fuel, 4% fuel I've added, just in order to keep the AFR correct. Otherwise it starts going lean. And then if I'm sitting in traffic for a long while, I have seen temperatures of 50, 52 degrees. But the air coming in isn't that temperature. It's just that the engine's cooked the air temperature sensor. Even though it's an open style one that's insulated and everything else, it still gets cooked. And so basically all I do is when you're in traffic, I open this up, try and get the air temperature up, and then increase this value until the AFR is back to where it should be. So and you can do this with data logs as well. Just go through data logs, but be careful not to boot it when it's running lean, because you don't want to, you know, have any detonation or pinking or go too lean. So it's worth bearing in mind that if the air temperature, if you suddenly find the engine's gone lean for some reason or other after you sat in traffic, or you've just switched it on after I sat there for 20 minutes, 15-20 minutes, then it's worth looking at these values here. So to look at a data log, look at the air temperature sensor values of what it was when you were driving normally, and then when it went lean, look at the air temperature, and maybe increase the correction a little bit. what you must also do is make sure one of them is set at 0. So anything below 35 degrees is 0. If you set that at 4, that'll always add 4%. So so the whole thing will be offset. So start one at 0 and then just slowly increase it as your engine might need it. I've got a gentleman who's got a his cooling fan is right in front of his air temperature sensor. So every time the cooling fan comes on in traffic, it heats up his air temperature sensor. So silly things like that. It all depends where you put your air temp, where you can fit your air temperature sensor. And the correction value. This is a whole scaling. Leave that at 100%. To be honest with you, this is to do with the ideal gas law, the actual calculation the whole system uses. And then this is you can use depending on as airspeed increase, as the engine speed increases, you can use a percentage of the coolant value in the manifold air temperatures calculations as well, but I've never had to do this, so I just leave this all at 0. This is just to compensate for the coolant value within the manifold air temperature value. I'd leave that at 0 unless you really know what you're doing, and I ain't got a clue about that part, so I leave that. So this is the main one, the manifold air temperature correction, non-linear manifold air temperature correction. The air temperature is compensated for within the ECU. So if I show you here, we've got, where's our if I just change one of these dials to pulse width, so we've got 10.7 pulse width going out. Ignore the value at 20 degrees C. So if I increase just the manifold air temperature, you'll see the say 10 degrees C is 11. As I increase it, the fueling comes down up to when I get to where my table correction now is. So as my table correction, my correction starts at 45 or 45 degrees. So now the pulse width here will start to increase as the manifold air temperature increases. That's just to compensate for the system. You may find that you may not need to add as much fuel as I have, but I like to be on the safe side of as far as fuel is concerned, especially on a boosted engine. So as you can see, naturally the manifold air temperature is corrected for, so up to 40 degrees that will naturally follow what it should do. Less air temperature, the more fuel added. The more air temperature, the less fuel added, up to when I get to my correction. Now it'll start correcting for that table that I've adjusted.